Well, again, my name is Chris Sanders. I want to thank you all for coming out today. I know there's a lot of ways you could spend your time, particularly in this wonderful city. So I appreciate you spending at least the next 35 or so minutes with me. Now, I've spent the majority of my career focused on SOC, eating, breathing, living, sleeping, dreaming, crying over SOC. That's involved a couple different things. At times that meant I was the one-man SOC. I did that a lot in educational spaces early in my career, where I decided to set up a very early instance of Snort on a public school network that had never seen packet analysis done before, and I saw a lot of things that could not be unseen. So that was an interesting entry point into the industry. So I did that for a while. I ended up working in and eventually building and leading SOCs for both the Army and the Navy in the Department of Defense. That eventually led me to a company called Mandiant, where I did more of the same. I consulted with a lot of SOCs, did a lot of applied research, and eventually I left to start my own company, Applied Network Defense, where we focused on teaching people about how to be a good analyst. And the key word for me there is analyst, because we're all analysts in some ways. Even if you are not necessarily an event analyst, you may be an incident response analyst, you are maybe a malware analyst, maybe you're a threat intel analyst. The analysis is a big part of that, and that's something that has gone largely unstudied in any sort of reasonable, even semi-formal way in the field. So my focus and my research area is really focused on the intersection of psychology and analytic work, particular to our field. And that also kind of intersects with the notion of how we teach and learn. Because to be an analyst is to be an expert in learning about a situation that kind of exists out there in reality that you're trying to make tangible to determine if anything bad has happened on our networks. So this talk is going to be kind of in that vein. We're not going to get too deep into the bits and bytes. My goal here is to hopefully make you think about some things in a little bit different way. And if anything else, I want you to walk away with the ability to accumulate experience faster. When I talk about the science of learning, that's what we're talking about here. Accumulating experience faster, because that's not always the easiest thing to do for analysts, really at all different skill levels. So the tool is called Mental Models for Searching. And really the reason I'm here today, because for my money, there is nothing more intimidating in a security operations center than this, or this, or this, or this. It's an empty search bar, and it doesn't really matter what vendor it comes from, whether it's Splunk or Sumo Logic. It's free, it's maybe Kibana, maybe that's sitting in Security Onion, something of that nature. It doesn't really matter. There's nothing more intimidating for an analyst, particularly a new analyst, than staring at an empty blank search bar that is really the only thing that stands between you and maybe all the bad stuff going on in your network. So we're going to talk today about search, and particularly mental models for search. A mental model, that sounds kind of fancy. It's just a way of thinking about the world, a way of simplifying things. So I'm going to talk about a few different mental models that allow us to simplify search and accelerate how we gain experience there. Now, part of the reason for this talk, again, I've lived, breathed, and eaten SOC for so long that search is a big part of what I do. I'm certain it's a big part of what all of you do. And I noticed that I and others often spend a lot of time just staring at an empty search bar. Right? What am I going to do next? How do I formulate the search? What do I search for? And so on. Matter of fact, we were actually even able to quantify that. So we have a tool. It's basically an investigation simulation tool. I use it in my classes that I teach, and people go through and they investigate things, and it tracks their movement. So you can go back and review what you did and learn about it. I'm going to show you here there are 3 different outputs from this tool. And I recognize the text is a little small. You don't necessarily have to be able to read all of it. But these are 3 different analysts, and this represents an investigation that each one of them did. And if you look at the biggest chunk on all of those, you see it's about 30%, 29.7%, all kind of in the same range. That is the blank search bar. And this is where they spent their time, right? So most of these investigations, one of these is kind of a newer analyst, one of them is kind of a mid-level, and one is more senior. They all spent a tremendous amount of time staring at a blank search bar. Now, I'm realistic. They certainly probably just weren't sitting there with their mouth agape, just staring at it blankly the whole time. Sure, they were maybe taking some notes. Maybe they stopped to use the bathroom. We've adjusted for some of that. But generally speaking, no more time is spent than just staring at a blank search bar. And I've done my fair share of that too. So there's certainly a need to understand how to be more deliberate about the searches we use and how to be quicker in that process. So that's what we're going to talk about today. And I think that really breaks down into kind of 2 main areas. One is simply what do we search for? I think that's the trickier one. The other is how to search for it. Once we know what we want to search for, how do we convert it into something that this tool understands so we can make our query? So we're going to focus in on both of those areas. Now, In terms of what do I search for? Well, that's a tough question, and that's something we're generally working on as analysts throughout the course of our careers. And I think a really good way to symbolize or to conceptualize this notion of what to search for is, well, it's this box that many of you have noticed here. Of course, we don't know what's in the box, hence the question mark on it. So I want to ask you all, we have this box. There's definitely something inside of it. I'm not tricking you. There is something inside of this box. If you wanted to know what was in the box, and knowing that I'm the only one that knows, if you happen to know you overheard something, don't ruin it for everyone now. But if you don't know what's in this box, what are questions you could ask me to figure out what is in the box? Anybody? How heavy is the box? How big is it? Definitely not bigger than this box. What is it? Where is it? It's in the box, I'll tell you that much. What else? Is it alive? That's a good question. I hope not. I didn't poke air holes. Is that no, that was not my car that got rear-ended out there. What else? What's in the box? Pretty direct, not telling you right now, though. Where was it purchased? Really good question. Anything else? Is it assembled? That's a great question, very specific. So there's a lot of questions you could ask to ascertain information about what is in the box, kind of working your way towards an answer. Now, what we did there was kind of an exercise in something we would call divergent thought. It's an exercise in creativity. We know there is this large realm of possibilities that exist, and we're asking questions that allow us to kind of reduce down the scope of possibilities that exist in the tangible world. So we're going to set the box aside or leave the box sitting aside for a little while. We'll come back to that now, but I want you to keep in mind this notion of asking questions because there are good questions and there are bad questions. Right? It's not like you're in school and the teacher says, oh, there are no such things as bad questions. There are definitely bad questions in the work that we do. This is the truth, unfortunately. So I want to talk a little bit about asking the right question. And to understand how to ask the right question, you have to frame that within the construct of a timeline. Now, as analysts, particularly as incident responders or event IDS type analysts, when we get an alert, that's basically some type of evidence that suggests that something evil is going on in our network. It doesn't tell us, it suggests. We're humans. We're the only ones who can make that determination. The machine can only suggest that it's going on. So what it is telling us is that there is a timeline that exists out there. We do not know a lot about it, but it exists out there, and our goal is to iteratively discover more information about that timeline such that we can build it out and make a determination, did the evil occur? If so, what did it affect? What do I need to do about it? And so on. That's the process, in a nutshell, of the analyst type work. Now, the tricky part here is you'll see I have event 3 highlighted there because in this example, let's say that's where we get inserted into this timeline. That's key. We really rarely ever get inserted into the very beginning of an attack timeline, nor do we get inserted into the very end of it. We're often in the middle, and the key is we don't know if we're in the middle. It could be the beginning, it could be the end. Based upon the type of evidence, it might suggest one way or the other, but we really don't know where we are. So what we have to do is generally ask questions that allow us to iterate upon this timeline. And that is kind of the essence of defining what is a good question and what is not. For my experience, generally most questions fall into one of 3 categories. One of those, what happened after the event that I'm already looking at? Again, probably an IDS alert, maybe something we found during hunting, maybe a third-party notification. What happened after that event? If we're concerned about what happened after the event, what else are we concerned about? What happened before the event, right? These are the 2 biggest categories, and the third one is simply context. We have all these things that don't necessarily exist temporally, so we have something like an IP address or a domain or a physical host or a user, and we need to learn about context about the nature of those entities and the relationships they have to devices, right? Is this an IT workstation that's doing this? Is it a finance workstation? Does this user normally do this thing? Those are context-based questions. So almost every question you're going to ask that is productive is going to fall into one of these categories. Moving forward in the timeline, moving backward in the timeline, or context about the things that are going on or the things you have discovered in the timeline. So this is really the key to start to think about asking good questions. There's a lot more that goes into this, but this is a good way to start that conversation and start becoming kind of metacognitively aware of that yourself. Metacognition is a word people like me say to feel important. It really just means thinking about thinking. So think of it that way. Metacognitive awareness is generally a good thing that we're lacking a lot of, but could do a lot better with. So that's all about asking the right question. Now, tying this back into search a little bit more, I want to talk about search workflow. And most folks, if I were to ask you what is the search workflow, they would say, well, that's a dumb question because you just perform a search and you get results, right? I think we really like to think that's what it is, but in reality, it's usually a lot more complex. And again, we've done a few studies where we're tracking the investigation process, seeing what people do, looking at the output from these tools, and we find it generally looks more along the lines of something like this. You perform a search, you get some results back, you either realize you're not getting the thing you need, maybe your search was too broad or too narrow, so you refine your search, do it again, you do it again, maybe you're shifting the question you're asking over time, or maybe honestly you just don't really know what you're looking for and you're just moving around the data kind of freeform. That's generally how the search flow works. And I think, well, let me ask this. How many people in here are in an analyst role and maybe are fairly new to it, maybe with like less than a year or two of experience? Show of hands. Several of you. Okay, good. So I think one of the things that really hurts new analysts is they often think that if they're doing the second thing here, if they're constantly refining their searches over and over again, that they're not good at their job. And that couldn't really be further from the truth. And we were actually able to quantify that to some degree as well. We found out that generally over 95% of searches involving investigation cases involve some form of refinement. So the vast majority of them involve that refinement. I will say the amount of refinement does decrease as analysts gain experience, but not a lot. Very little. And it's not so much that the refinement goes away, but instead of refining a search 6 or 7 times, that person may refine it 4 or 5 times. So there is an improvement to be observed there and something that you will generally get better at, but refinement is a natural part of search, and I think once you start to accept that, it helps you not be afraid of it, you embrace it, you kind of move on from it, and I think that's valuable. And again, even highly experienced analysts rely on that level of refinement. Now, when we think about refinement, well, what does that actually mean? I've kind of hinted at that already. Refinement generally involves either expansion or reduction of your search. So we can do that a couple ways. An expansion is obviously taking a smaller subset and making it larger, very clear. So if we're doing that based upon time, we might go from a day to a week or a second to an hour. If we're doing that based upon criteria, well, that criteria could be anything within the data. One host to a lot of hosts, one host to a lot of, or one port to a lot of ports, so on. A reduction, pretty simple, right? It's just the exact opposite. You're going from a big number down to a small number, often based upon time or criteria. So when you're refining searches, you're generally doing these things, but you're not necessarily doing them kind of in a vacuum or in an isolated nature. You're often doing them in pairs or in conjunction. And let me give you an example. So let's say you're doing maybe some hunting, and you're looking at event ID 4688. What does event ID 4688 tell us? Process creation, right? So processes has potentially run on our systems. Maybe we're looking for generally malicious processes or processes that we've never seen before that we want to investigate. So search 1 is just that. And we search for all Windows Event ID 4688 events over 1 day for all of our servers. What's going to happen if you run this search on your network? You're going to have a bad time. You're going to get a lot of data back probably if you're on a network of any reasonable size. So that's not a great search. So we probably want to refine that a little bit. So in search 2, we're still doing a day, we're still looking at all servers, but now we're taking a list of known applications. So maybe all the things that are built into Windows or Linux or whatever operating systems we're running, maybe the known applications we have installed on all of our gold images that we distribute throughout the network, maybe just commonly downloaded applications. We're building a list of those and we're excluding that. So what we have here is a refinement, it's a reduction based upon criteria because we're excluding things. So we do that and we get a much smaller list back. We're having a better time now because we're having a lot more manageable set of data that we can work with. So we do that, we exclude all the stuff down, and we find something that's interesting. Maybe we see an executable that's kind of vaguely named and it's run on some systems or one system, at least one of these servers, and we want to learn a little bit more about it. So again, we're thinking about questions here. And one of the questions I'm probably going to ask myself if I find an executable running on a host and I want to know if it's normal is I want to understand maybe how many times it's executed. Right? Remember, I'm only looking at a day here. So what I'm doing in the third search, again, still event ID 4688, I am doing, in this case, an expansion based upon time. So I've gone from a day to a week. I'm doing a reduction based upon the host. I've gone from all servers to just the one file server where this executable was run on. And then I'm still excluding the unknown apps at that point. So what I'm trying to see here is this thing that I think is suspicious, did it run once? Is it running on a periodic basis? Is it running every hour on the hour, every day on a specific time? I'm trying to answer that specific question to help characterize the nature of this executable. That may not be the best question or the first question I would go to, but it is probably one, particularly since I already have that data in front of me and I'm already doing those searches, that I would consider answering during this investigation. The key point here being that expansions and reductions generally go together and are not completely separate things, and they're all forms of the refinement that we're doing. And this gives you a little bit better way to conceptualize the refinement that you're doing in your own searches, and a way to talk about them in a more uniform way with the other people in your SOC, which is a highly underrated thing. Now, I have a question for you. So we have a couple options when we're doing kind of our initial searches, our opening move sometimes, as I like to call it. One of those options is you start with a really broad search and go narrow, 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 narrow till you get the thing you want. The other option is to start really narrow and expand, expand, expand until you find the thing you want. I would like a show of hands. Who thinks the more efficient way to go about, generally speaking, investigation is to start with the broad search? A few of you. How many think you would start with the narrow search? So pretty split room. Good. Controversy. I love it. So generally speaking, from what I've observed, it is generally better in an alert-driven investigation or an investigation that's driven by a clear piece of evidence to start with a narrow search. But the reason being that narrow searches mean you're generally asking specific questions. Specific questions get specific answers, and it allows you to move through the investigation in a faster way. The tricky part with narrow searches, and this is particularly the case for those of you who are newer to the field, the reason most of us don't run narrow searches is because we are not confident enough in our own abilities, and we are afraid if our search is too narrow, we are going to miss the important thing, right? We often see that based upon time-type criteria. So I know the thing I probably need to see is within probably a few milliseconds of the thing that I just looked at, but I'm going to go ahead and pull PCAP for the whole hour, right? I see a lot of heads nodding. You've all done it. I know. I do it all the time, still sometimes. It's a confidence thing. And as you build more confidence, you start to get better at narrowing in those time ranges. And from what we've seen in our measurements, it is almost always significantly faster to start with a smaller data set and add as you need to. And that's not to mention not just the human side, but the processing side, right? So if you grab a bunch of PCAP, well, you have to download that from your sensors, you have to pull it all back, you have to run through it. If it's too big, you have to use TCP-num to carve it down, then you pull it into Wireshark, and there's this whole thing. Whereas if you just started with the smaller data set, maybe a particular conversation or a very small time window, you're generally going to be a little bit more efficient in that regard. Now, that to say, broad searches have their place. Broad searches are often really useful either when you've run out of leads or you're struggling with the timeline or you know a host is maybe infected, but you kind of run out of good questions to ask, so you're going to pull in broad data set and do a little bit of manual analysis or maybe in some type of statistical analysis, feed it into something like that. That's very useful. So broad searches do have a place, but it is almost always more efficient to start with narrow searches, and the thing I would encourage you to remember is that specific searches get specific results. So if you're asking great questions, you want a specific search. If you're asking crappy questions, and you wouldn't know you're doing this at the time, but if you miss something, it's probably because you asked a bad question, and your search, if it was specific, missed the thing you were looking for. It's that whole notion of accuracy versus precision. Ideally, we are both accurate and precise. It doesn't matter if we're precise, if we're shooting at a target, if our cluster of arrows are all the way over here. Right? That's what we're thinking of when we think about specific questions. So those are just a few notes on kind of what to search for. That's a bigger topic than we have time to talk about fully today, but a few things to get you started on ways to think about that, building some of those mental models. Now, the second part of this, I want to talk a little bit about how to search for the things. So maybe we know the question we're asking, we know kind of the search we want to make, but we have to convert that. We have to make that generally useful in a way that it can translate to the tools that we have at hand. So questions manifest in our tools as syntax in the various searches that we have available. From the surveys we've done, the average security practitioner will use 4 search systems in a 10-year career. And when I say systems, I mean unique syntaxes. So I'm not saying like SQL is one of those things, and you might use SQL across a lot of technologies, but that counts as one in this case. So over a 10-year career, you can plan on using 4 of these. Most folks that generally manifest as one kind of free or open source thing that you see a lot of, and one of them normally manifests as some type of commercial tool, basically whatever you're using at your workplace, right? And those take a number of different forms. A lot of different security tools listed here. A lot of vendors have their own query languages. We've seen people using some Splunk processing languages today. These come in a lot of flavors, and pretty much everyone at some point is going to have to use regex and maybe accidentally crash their Elastic cluster twice. So you're going to learn these, and you have to kind of get good at learning them. And I will say they're tricky to learn at first, particularly if you're new, but it's one of those things where if you learn one of them, it becomes a lot easier to learn another. If you learn how to search programmatically, you can translate that to other things. And that's kind of the same advice folks would give you if you're learning a language, like a spoken or a written language. Once you learn one, or in our case, we're all born learning one. Once you learn your next one, learning the others tend to be a lot easier to some degree. And I think there's some parallels to be drawn here, not necessarily in that capability, but in how spoken and written languages are modeled from a teaching and learning perspective. And if you've ever learned languages or spent time in language studies, then you may not have seen this model, but you've certainly heard some of these words like phonology or morphology or phonetics. And even if your instructors don't use these are basically what you're teaching or being taught. These are the things you learn if you're learning how to speak or write a new language. I don't think this is the model we'll use, but I think we can use a model somewhat like this. And when I break down a search tool, I generally break it down as such. I think the things that you need to learn are the back end, the syntax, how to do partial matching, how to use special search features, and how to manage the output of that search tool. Now, again, we have a short talk here today. I can't go through all of these in extreme detail, but I am going to go through several examples of a couple of these to help you think about how you can better learn your search tools. Again, my goal here, I'm not going to teach you how to use Splunk processing language in the 10 to 15 minutes we have left. I'm hoping I can teach you what you need to look for and what you need to plan to learn to get better at the next search syntax that you're going to have to work with, or even your current search syntax if you're not really comfortable with it. So we'll start with the back end. You can spend a lot of time learning about search backends, and I would say if you did, you would probably be wasting most of it because unless you're you're doing computer science and developing these things, you don't really have to get into the nitty-gritty of something like a relational database versus a graph database versus an inverted index, which is kind of like the index in the back of the books, physical books. But you needed to learn the basics of how the data is stored because it is going to, in some ways, define the queries that you make and the structure that they look like and your accessibility to the data. And let me give you an example of this. Most of us are familiar with, or at least have heard of, SQL, structured query language. It's not necessarily thought of as a security thing, but it's used often with security tools. If you're doing web-based stuff, whether you're attacking web apps or defending web apps, you're eventually going to run into some SQL queries. If you're using something like OS query, it's based upon SQL. So there's certainly a need to know that in our field, depending on what you're doing. So SQL is stored in a relational database, and a query might look like this, where we want to just simply see all the users who are in the finance department, and the back-end data is stored in a format kind of similar to this. It's kind of tabular focused, that the tables and the columns are kind of the first-class citizen. And we'll compare that with something like Cypher. Cypher is a query language used for graph databases. Most commonly, Neo4j is one that uses it that's quite popular. And a very similar query for Neo4j would look like this, and that's kind of confusing if you've never seen it before, but it becomes less confusing when you look at the data model. Whereas in this case, we have finance as that kind of purple node in the middle. We have the human nodes outside of them, and you see the lines connecting them. Those lines are relationships, and they have properties as well. So it would say Bob works in finance. Sally works in finance. Works in is the relationship, and it is how it is defined. Actually, it looks like it's works for is the relationship there. So once you understand the data, you can kind of see how the query shapes up, and you can see how you might traverse that data. I think the ironic thing here is whereas SQL is considered a relational database, something like Cypher, which is a graph database, is actually much more focused on relationships. That's kind of confusing, but just a general observation about those things. So you want to understand, again, the basic data structure that supports your data because it will limit or provide you the features you need for searching through it in an effective manner. Now, the big booger we have to deal with is syntax. This is the one that gets everybody. Because syntax is confusing, and syntax is particularly confusing when you have to learn or manage more than one tool. I mentioned most folks generally will learn one free open source, one commercial. I think probably the two most popular that I see the most of are something Lucene-based, like Elastic, or Splunk is probably the most popular commercial one that I see out there now. So again, the differences between these things are just slight enough to be insanely annoying. So in this case, if I want to search for something in Lucene, again, like Kibana, I'm going to type field colon value, or if I want to do it in Splunk, it's field equals value. And if you live in the world where you're using both of these things, you will get it wrong all the time, and you will slam your head against the keyboard, and you'll curse the name of Lucene and Splunk constantly when it's not really their fault, but gosh, guys, couldn't we just get together on this? I don't know. So the change is just enough to be, subtle enough to be annoying. And it's not always as simple as that, too. So we have compound queries, and we understand compound queries. You want to search for one thing and another thing or another thing. We understand the difference between an and or an or. And that syntax is pretty common amongst most tools. If you're searching for two things and you want them both to match, you use an and. If you're searching for two things and you only need one of them, you use an or, and it's generally the language and or sometimes you have the ampersands or the pipes. So pretty straightforward. That's pretty similar, other again than those pesky colon versus equal sign that we see there. But what about this? So this is searching for source port equals 80 as well as source port equals 53. Is this an and or an or? It's an and, so we know who the Splunk users in the room are, right? So Splunk defaults, if you don't put anything, it defaults to an and. And you wouldn't know that until you've tried it the first time. So in this case, what's wrong with this particular search? Why is it not a good search with that in mind? Yeah, you're not going to get anything because almost every data point that I can think of is only going to have one source port field. You're not going to have two. So you can't be source port 80 and source port 53. Now you can search for source port 80 or 53 and get the things that match either, but no data is probably going to have both of those in most of the cases that I can think about. So you have to understand what the defaults are, and sometimes that means reading documentation, but let's be honest, none of us are going to do that. So you have to bang your head against the keyboard a couple times before you really figure that out. Here's an example in Lucene. So we see here we have domain specified, which is the field, and then we have parentheses, and we have several domains separated by commas. Is this a default and or an or? It's an or, right? So it wouldn't, again, kind of the same deal. You're generally going to have one domain field. You're not going to have multiple. So if you're matching all those, that'd be a little weird. So you can kind of deduce it from that a little bit. But again, these are simplified examples. It's not going to always be that simple. And this is handled differently than how Splunk would handle it. So what you're having to do here when you understand syntax is you want to understand how compound operations are done and what are the assumed things that are being applied to your searches. Again, default and versus default or, the different manifestations of those things, etc. One more example. I gave the same presentation at another summit, at the Blue Team Summit recently, and I had a couple gentlemen from Splunk sitting in the front row, and I put this on the screen and they laughed out loud because they said this is the single number one thing they get asked about in all of their troubleshooting and support efforts. What we're doing here is we're matching, we basically want to match any data where the username does not equal, where it has a username field and the username does not equal Chris. And there's two ways you see that I'm doing that. Username exclamation point equals Chris and not username equals Chris. Now, if you don't know any better, those sound like they do the same thing. They do not do the same thing. Spoiler alert. The top one is the tricky one because it will actually match anything, not just where there's a username and it doesn't equal Chris, it will match anything that does merely not have the username field. So that's going to get you a lot of extra data you didn't need or didn't want, and that's going to cause you a bad time. The bottom thing is the thing that you want, because that means the username field has to actually exist and then not equal Chris in that case. That's a very subtle thing, and search syntaxes are full of those little things. It's ultimately a good thing because it simplifies and gives us more flexibility. There are cases where the first example, I might want to use that. So the flexibility is good, but again, you're not going to know about this. If you start searching for this, again, I think this is also one of the most liked and favorited Splunk help articles that's out there. So we see a lot of that. So that's syntax. I'll talk really briefly kind of about partial matching because this is really critical. A lot of times we have a fragment of something and we want to match iterations of it. So maybe we have the stem of a username or the stem of an evil URL. So we have to learn how partial matching works in our search tool. And that is also one thing that fortunately is generally fairly static. So wildcards are generally the way we do that. A question mark will generally basically says substitute in any one character for the question mark. The star, the asterisk, says substitute in any number of random characters, letters, numbers, etc. in for that. So you see I have the examples on there. ST question mark AK will match steak, or ST1AK or STQAK, whereas ST star AK will match really all those permutations you see. So I think most of us kind of understand that, and fortunately that's pretty static in search tools. Now, one of the ways search tool documentation sometimes gets you is it uses terms like prefix search and suffix search. And this throws a lot of people off, but it's really just it's not additional functionality, it's just additional words to describe the type of search you're doing utilizing these various wildcards. So a prefix search basically means you have a prefix and you're searching for other things after it. Suffix means you have a suffix at the end of a string and you're searching for the things before that. So don't let that trip you up. Again, those are words that just kind of appear in search documentation that can trip you up as well. And I'll end talking about the feature sets of search just very quickly with talking about features and output. I kind of combine those because it's so wildly variable between the tools that you're going to use. One of the features you're going to have to use a lot of are ranges, so you don't just want to search for one port, you want to search for everything from port 1 to 1024. So how do ranges work? In this case, I believe this is the Lucene example, 1-1024 would be the way to do that. You also may want to search for exist. Does a field even exist? Maybe you have a bunch of proxy logs, and some of those are username aware, and they have a user account associated with them, and some don't. You only want the username aware ones, so you use exist to search for where the username field actually exists. Now remember, there's a difference between a field existing and a field existing and being blank, right? There's a difference, so you have to be aware of that. Regular expressions are pretty clutch. At some point, if you're in security, you're going to have to use regular expressions. It's worth taking time to at least learn some of the basics. Otherwise, you're just going to have a bad time every time, and I put it off for a long time before I devoted time to learning regular expressions, and it really made things a lot easier for me. So basically all this to say that different search tools have different bonus features, so to speak, that are critical in the analysis process. I think these are really 3 or 4 of the most critical ones. Sub-search, we don't necessarily see a lot of that. It's a lot of the time for performance enhancement. Performing a search and then doing another search within the results of that search. You see that a lot on like Elastic type stuff where you're really concerned about bringing down clusters unintentionally. Again, not that I've ever done that in production environments spanning all 7 continents. Output, I don't have a lot to say about output other than most of the time our output is coming to the tool that we're using and we're pivoting off of it. Spend the time, learn how to export output from your search tool to CSV or JSON. For my money, those are the gold standard. CSV if you're going to do some command line based analysis, JSON if you need something structured and you're going to do some programmatic based analysis. So those are really the 2 formats that I think are the best bang for the buck. There are certainly others, but these are the ones I expect most of my search tools to use. Now, last slide, and I think this is the big one. I'll change to it here in a moment. I think, I'm talking through all these different things, and I keep telling you, you should learn this, you should learn this. Again, when we talk about mental models, I'm trying to give you a framework for things that you can learn to accelerate the experience you're gaining. So I summed all these up on one slide, and it looks like this. And this is basically Chris's magical guide to getting good at any search tool. So if you're going to take a picture of any slide like this gentleman's doing, this is the one to do, although the slides will be up later, so maybe you don't have to do that either. But this is a lot of the things we already talked about, and a lot of things, honestly, I didn't have time to talk about today. So things like Boolean operators, how to escape characters. We have to escape characters all the time in the searches we're doing, and that can be very frustrating if you don't know all the rules that go to it. So if you're new to this field, if you're learning a new search syntax, if you have a new tool, maybe you had in-game and you bought Splunk, or you changed from one tool to another, this is the guide to getting good at any search tool much quicker, and I wish I had this when I started my investigative work. Again, it's really just a list, but lists can be good. And this is a list that tells you how to focus your learning and kind of your learning plan from me to you. So, again, my name is Chris Sanders. I blog. I teach a class about this stuff called investigation theory. It's online. There's a link to it there. And I'll open it up to questions, keeping in mind that I'm also the guy who just talked about there are definitely bad questions. So,
do we have any questions for Chris? Come on. There we go. Somebody's got a question. We got one here. Go to him first, and then we'll go to you afterwards. Whoa. Don't trip.
I thought we were getting back to the box.
Bingo. Okay, that's the question. That's the only question I'm actually going to answer. I was going to see how long,
What's in the box,
to get it. I'll answer other questions if you have them. I'll be around. So we have the box, and I guess this is my motivational part of the speech. Because, again, search is super intimidating. I didn't start with that just because I thought it was cute or an interesting introduction. Search keeps people from being analysts. Being an analyst, as many of you know, is a hard, demanding job. I know John Hubbard's going to talk a little later about burnout, right? And I know we're all really looking forward to that talk. And you burn out easy. And one of the things that makes this job much, much harder is all we have to deal with in terms of learning. It is hard to learn how to be an analyst. So that's something I think about a lot. And I think if I could say anything to the new folks, and I saw several folks who were new when they raised their hand, I think the beautiful thing about being a security analyst, and particularly the beautiful thing about searching, is that you're really never run out of extra lives. I'm Chris Sanders. Thank y'all so much.